We're the replacement group, and everybody's having fun, and we're having fun, but we're also dead serious about this. What we did is we had a goal. The goal is a proof of concept for full body replacement in humans, in a human, which means, let's say, less than 10 humans. One is enough, but you need to, let's say, do it in 10 humans until probably you get to that one human. So what is out of scope for us is we don't need to do brain replacement for this, and we also don't need to do this to 100 humans. We don't need to convince the public. We don't need to do a lot of convincing anyway. What we did is we reverse engineered what needs to happen for that proof of concept in humans. And surprisingly, it's pretty simple. What needs to happen is we need one replacement body for a human, and we need the nerve reconnection surgery to connect that old human, take its head and put it into the non-sentient body, and that's basically all that needs to happen. Now you can ask, what do you need to do for the nerve reconnection surgery to be available? Chris, where's Chris? I don't know why he participated in another group, but he's working on that, and Sean. So if there are any further questions about costs and steps, you should talk to them. What they basically have to do is prove that Ran and Canavero are right, who tried this in monkeys before, correct? Okay, and replicate that at scale, or at least enough so that you can perform it safely in humans. On the other hand, maybe the bigger question is, what do you need to do for the body to be available, right? The non-sentient human clone. What you don't need is, you don't need like some fancy artificial wombs. You can just do it in a human womb. And you also don't need a cage or something to grow the human in. You can just grow it in a room with nurses in a hospital. So it's pretty simple. What you do need is you need a woman who gives birth to a clone, and you need to take care of that clone until age 18, which can be debated. Perhaps you can also do the transplant at age 12. So what needs to happen for that to become possible? You need to run a couple of experiments to identify the optimal age in the human, and that's really hard to predict how much that is going to cost and what the risk and success rate is. So first of all, you need to do a proof of concept in monkeys. And our expert from our group estimated that the cost for a full body replacement in monkeys, including cloning and growing the non-sentient clones in monkeys, would only cost $60 million. And on top of that, we'd need an additional $100 million to replicate that in humans. So the really surprising thing to me is that for only $160 million, you can get to a stage where you can work on a proof of concept for full body replacement in humans. Now you probably need a clinic dedicated to that surgery and everything around it. Maybe that clinic can be an extension of the facilities that you use for the stuff before, and maybe at the same place where you do the monkey experiments. I don't know if you want to save costs, but bottom line, 160 million would get you very, very far in replacement. So my question is, why would you work on anything else if it's so cheap to do replacement?
Thanks. You. Do we have a mic somewhere? Oh, great. I think Michael has a question. Are you answering the question why work on anything else?
I can answer that, and I can also answer.
Maybe push back.
Well, why I would still work on something else is because the brain is one. And second is I think it's a highly, highly non-trivial thing to scale. And third, I think the biggest issue of all is the very likely public pushback against that once it grows beyond like very severe, very obvious cases. Having said that, though, I think you could maybe even do it cheaper and faster. So things like twins, right? Or things like relatives that have, one of them is sort of paraplegic, the other one is kind of brain damaged, you have at least a partial immune system match, right? Maybe you could do it this way, like today.
All right. We're at time. Thank you so
Okay.
much.